My name is Shayaan Naseerkhan, and I made a bike speedometer, which I called Shai's Bike Speedometer. Wait, are you guys hearing that?
Uh, no.
Oh,
If
because
you
it
go to
just
the top at the,
repeated what I said. All right, so biking. Biking is both fun and dangerous. Many of us who have bikes enjoy it, but it is also dangerous. Anything that could be done to make it safer should be done so that more of us can enjoy it with more peace of mind. Bike speedometer can go a long way in making biking a safer experience. So why do we need it? Biking is not 100% safe, and a speedometer's information will put you in a better position. For instance, if you are going downhill and you're coming up to an intersection, it would be good to know how fast you're going and how long it takes you to stop. If you don't know how fast you're going, you're just guessing how long it will take you to stop. So with a bike speedometer, you can help understand a bike speedometer can help you understand the braking time and the braking distance. Knowing speed helps you plan ahead time-wise, thus lowering stress. For instance, if you need to make it somewhere in a certain amount of time, knowing how fast you usually go will help you determine when to leave so that you can get there on time. So the solution. Shai's bike speedometer will use the time between rotations of a bike wheel and the wheel circumference to find its speed. An Arduino is essential for this because the speedometer requires code. The information will be relayed from a Hall effect sensor, which is attached to the fork on your bike, and the speed will be shown on an LCD. A Hall effect sensor detects magnetic fields and outputs a signal which can be interpreted by a processor such as an Arduino. Hall effect sensors work because of the relationship between electricity and magnetism. In it, a small metal strip has a current that passes through. When a magnetic field is present, the electrons on that strip shift towards one side. This will make it so that one side is positively charged while the other side is negatively charged. And now there is a voltage difference between the two sides, which signals the sensor to release a digital output. Furthermore, there are two types of Hall effect sensors. There are linear Hall effect sensors and threshold Hall effect sensors. Linear Hall effect sensors work by sensing how strong a magnetic field is and sending out an output that matches that strength linearly. Whereas a threshold Hall effect sensor works only when a magnetic field is strong enough. This has usage in cases such as my project where I don't need uh, the Arduino to know how strong the sensor or the magnetic field is. I just need to know if the magnet is passed. So on the left here is a Hall effect sensor. The furthest left pin is the input. It's 5 volts. And the middle pin is ground. And then the right pin is a digital output. And also between the 5-volt and digital output, you need to add a resistor so that the digital output actually sends out a voltage. That was one of the mistakes I made when I was first starting out. So my design. These were my initial sketches. The image on the left is more of an overall image. And as you can see, there's small circles around things on the bike, and then they come out with bigger circles to actually show you what it is. So the circle on the bike spokes, that's the magnet. And that lines up with the Hall effect sensor, which is attached to the fork. And then the Hall effect sensor sends its signals, sends its ground, and gets its input from the contraption by the handlebars, which contains an Arduino, the battery, and the LCD. And the second image shows how I was going to mount it to my bike using Velcro strips. I would have a Velcro strip attached to the bike and a Velcro strip attached to the container that contains everything. So then parts. So there needs to be a magnet which is attached to the wheel and a Hall effect sensor. Now this Hall effect sensor is very small, if you can even see it in the picture. The size of the tube is about 1.5 inches thick. So from that you can see that the Hall effect sensor itself is very small. It can sense magnetic field and sends an output with the necessary information, but you have to make sure you line it up with the magnet you attach to the wheel, otherwise you'll miss out and you'll get incorrect data. And then an Arduino will keep track of time and count the number of rotations from the Hall effect sensor output. With some coding and a known circumference of the wheel, this can calculate speed. Over here on the right, you can see an Arduino, and that's not even all the wires it took to complete this project. Those were simply just the wires for the LCD, which was challenging to wire at first, but once you get it, it looks good. So then here is my LCD display, and it displays the speed in kilometers per hour and miles per hour, as well as shows the milliseconds per each revolution. And then for the code, the pathway the code follows is to calculate speed every time it receives a signal from the sensor. This is simpler than having the Arduino continuously calculate speed because that requires a lot more computing and it might change too fast for one to notice on an LCD. That was my original plan for the code. It just kept on telling me that I had 0 for my speed, even though I didn't. And I tried to figure out how to fix it, but there was just too many variables. So I decided to change how it works. So the current code uses the seconds between rotation and the wheel circumference to calculate speed in meters per second. From there, all that is necessary is converting the units from seconds to hours and from meters to miles or kilometers. So this is my purchasing report. The Arduino Uno we had to buy for class, but I only had to use the Arduino and the LCD from it. And then the Hall effect sensor came in a 10-pack for about $6. I had to buy extra wires because the wires in the kit were not long enough. And then I bought a pack of magnets to use with my Hall effect sensor. So I also had a survey to see if my product would be worth it and if people would even consider buying it. The first question I asked is, do you enjoy biking, whether you own a bike or not? And a majority of people actually said yes, which makes my product viable because people usually don't spend money on items they do not like. Whereas if they do like something, they will spend money on it. I've seen people spend money on shoes, cars, and everything. So if they like bikes, they might as well spend money on a bike speedometer. And then I also gauged whether people currently own a bike or will own one in the near future. And about 2/3 of the people actually own a bike now or will own one in the near future. This is a pretty sizable audience, and it means I don't have to have people go out and buy a bike in order to sell my product because people already have bikes. And then I asked, would you like to know how fast you are going for safety or for data reasons? And the response to this question was pretty positive. 75% of people who own or will own a bike are potential customers for my product. This is a large number and shows that there is a lot of opportunity for this product in the market, considering that most people probably don't have a bike speedometer yet. So then the last question I asked was about the value. How much would you pay for a device that will tell you your current biking speed? And most responses were between $30 and $50. And there was even a response in euros, which means that my product could even be sold in Europe, which is something I did not expect at first. But when you think about it, it makes more sense because they probably bike more with some of their smaller streets. So some analysis of this stuff. Based on the responses to all the questions above, there is a sizable interest for a bike speedometer. And I think this product is profitable because if I only buy the necessary parts, it isn't out of the price range. The prices for the sensors, wiring, and magnets are minuscule per product. And buying an Arduino Uno on its own is about $30 and the display is about $10. If I looked harder or considered buying everything in bulk, it would probably take less than $30 per product and I could definitely sell it around $40. So this is my per chart. It's pretty linear. It goes from left to right. And as I was on my own, I kind of had to follow this if I wanted to get it done. It started off with my research, went through designing and purchasing, all the way to a final design and build and testing that as well. And this is my Gantt chart. At the beginning, I fell a little behind because I found out that maybe I needed a different magnet. But after that, it's been pretty much on track, and I was, in fact, able to finish the product. So now the human factor for this product is curiosity. Curiosity is something humans naturally are. You know, we want to touch things, we want to play around with things. And my speedometer displays the speed in kilometers per hour as well as miles per hour because people just love to know more. All right. And also, all the parts are visible because people also love to see how things work. Usually, when you buy a mainstream product, everything is hidden off, but this is safe enough that it can be visible. And if you wanted to, you could take it apart, and I would include instructions to rewire everything. And this was my final product. One issue I did find was that the Velcro was not strong enough to keep the product stable. The tape and the plastic wrap that are going to be shown in the test video were used to keep it stable. If I had more time, I would have done something that looked more professional and that would have actually sold as a product. And this is a video. All right, so for the conclusion, I was able to build a working bike speedometer, even though it seemed pretty hard. This product can, in fact, make biking safer, and with more time, I feel like I would have been able to improve the build quality, and maybe with some extra help, since I was on my own, I could have gotten an even better code that maybe showed more digits or was neater. Thank you.